Hello, and welcome to my Mantra Effects Rendering Foundation course. For this very first lesson, we're going to begin with a practical overview of rendering in Houdini. This is to bring you up to speed with the very basics and introduce some best practice techniques so that everyone has a solid foundation before we get into the more effect-specific topics. So we're looking at the object level of this scene, and as you can see, we have three netboxes. For a simple scene like this, it's obviously not such a big deal, but it's good to be in the habit of grouping objects, so that when you start working on larger projects with other Houdini artists, it's easy to open up a scene file and find what you're looking for. I've seen some very messy hit files in my time, and it makes everyone's life a little bit harder. So you'll notice that we have a netbox which is named Assets, this guy here. We have one which is named Effects, and we have one which is named Render. The general idea of this layout is that data should flow from left to right in your scene. So we bring assets such as cameras and assets into this netbox on the left. Then we'll do things to them such as effect simulation in the middle. And then we'll render them or perhaps write them out for other departments on the right. As you can see, we already have a camera, we have a ground plane, and we have a couple of objects called rebelchunk_1 and rebelchunk_2. Even though the display flag is off for these objects, you have a pretty good idea of what they might be because I've given them descriptive names. And I think this is a practice that's worth following all the way through your work in Houdini. So if I unhide these, there's one and there's two. So as you can see, these are fairly high-res scans of pieces of rubble, and we'll be using these all the way through these lessons. We aren't going to render any effects in this lesson, so we're going to leave the effects netbox empty for now. So let's move to the right and have a look at the render netbox. Right now it only contains a single object, render_ground. Let's take a look inside it. Right now this object only contains two nodes. There's an object merge and there's a null, which I've named render in all caps. All we're doing here is grabbing the contents of the ground asset and merging it into this object. The null is named render, and it's here purely as a place to set the render flag. The render flag should stay in this node, and then it makes it simple to insert other nodes you might need in between and know that the end of the chain is already defined. Similarly, the reason for having a separate render object for the ground is so that we can get the assets and effects and so on, how we like them, and then have a separate place to do things that are specific to rendering, such as attaching shaders, computing motion blur, and so on. So let's duplicate render_ground so that we have render nodes for our rubble chunks. I'm going to Alt-drag to duplicate these and snap them into place so they line up with nodes on the left. In fact, let's do this. And drag them all so that they all line up. Okay, I'll hide these and dive inside render_ground and point this one at rubble chunk 1's out node. If you notice that this null is named in all caps, it floats to the top of the operator list, so it's easy to select. So I'll accept that, and I'll just set this to merge into this object, so it inherits the transforms. And I'll do the same with ground 2. Okay, I'll set the display flags on these. And of course, we should rename these to reflect the names of their source assets. What else do we need in order to be able to render these objects? Well, Houdini will very obligingly autocreate ROPs, render operators, which is what it calls its output nodes, and these will also in turn create their own basic headlights. But it's better to create these things ourselves so that we have some control. Let's drop down a couple of lights so that we can actually see our objects. We'll make an environment light first. there's no need to pick a location for an environment light because it's shining from all around our scene, which is a good reason that it makes a good first light to add. Because it's a rendering node, we're adding it to the render netbox to keep it tidy. And let's also create an area light, which we will need to place, and we'll point that at our rebel. And we'll add that to our render netbox as well. I'm just going to boost the exposure in that a little bit. There we go. We'll also need to add a ROP, or render operator. These need to exist inside a ROP or out context. Houdini has a standard place for these, which is /out, which is here. There are some pros and cons to this location. It's good because it's a standard location that exists in every HIP file, but many Houdini artists and the teams they work with will decide that it's better to keep everything under /obj because that makes it easier to find things and it makes transferring scenes simpler. I subscribe to that philosophy, so let's go back and let's create a ROPnet under /obj. I'm going to tab down a ROPnet, like so. And that can also live inside our render netbox. So let's dive inside our new ROPnet and drop down a mantra ROP. Different renderers in Houdini have their own ROPs, and for mantra we'll need a mantra ROP. By default, the mantra ROP will render through cam1, which is the default name for the first camera added to any Houdini scene file. And that's what we have. And it will also render all visible objects and lights. As I mentioned before, if it doesn't find any lights, it will shine a light straight from the camera into the scene, although you can disable this behavior. But it's generally set up to be smart enough to make some sort of image, because it's always easier to debug a render that is incorrect than one that's just black. Mantra will name output renders with the name of the ROP, so it's important to always name your ROPs, or you'll end up with a lot of renders called things like Mantra 1, Mantra 2, and so on. So we'll go ahead and rename this. We'll call it Mantra Rebel. Next, let's do a render. There are a number of ways of starting a mantra render from inside Houdini, so let's go through them. First off, there's the render view. I find that this is where I do most of my test renders. If you can't find it, which I'll simulate by deleting this one, you can recreate it by going to New Pane tab type and down to Mantra Rendering and choosing Render View. We'll start our render using the Render button up here on the Render Controls toolbar. We can choose which ROP from a list and which camera to use. You'll notice that our render is building progressively. This is because the render view defaults to a gradual refinement mode. It'll do a rough render as quickly as possible, and then it will progressively refine it. It's also an IPR, or interactive photorealistic renderer, which means that it caches as much data as possible, and will interactively update the image as you change settings. So let's just choose our area light and change the color slightly. And we can also make this go faster by choosing the relighting buffer. So now if I hit green, it switches even more quickly. So this is great for quickly zeroing in on the general look of your render, but when you get into more detailed refinement, like cleaning up noise, the gradual refinement feature isn't so good, because it doesn't use the same anti-aliasing techniques as the normal renderer. When you need to do this sort of critical evaluation of render quality, you should disable gradual refinement. The renderer still caches data to improve interactivity, but it'll render in buckets, and the anti-aliasing will match a normal mantra render. You can also choose which area to focus on by dragging your mouse around. It's also worth noting that non-gradual refinement renders are significantly faster, and also that, at least in my tests, when you have gradual refinement on, the blur option seems to be quicker sometimes than the sharp option, and it has better anti-aliasing. So I'm going to pause this render, and we'll go through the other toolbars. Some of them are open by default, and some of them aren't. It's a good idea to expand them all at least once so you know what they do. As we already saw, the render controls bar at the top allows you to start and stop renders, choose which ROP and camera to render through. You can open the parameters for the ROP and for the camera. You can choose your update mode, whether it's blurred or sharp. You can choose how quickly it will start rendering once you change the setting, and things like that. The color correction bar at the bottom allows you to choose different channels to display, so you can go through different color planes. Alpha, which is white in this one, and then back to all of the color planes. You can choose to change the brightness, the contrast, and the brightness shift. So I can crank that up in stops and then reset it. I can increase the contrast like that with the mouse wheel and then reset it. And I can increase the bright shift. So I'm essentially just adding brightness globally to the image. And then on the right, I can change the gamma. So lower gamma, higher gamma, then reset it. I can choose a LUT from here, or I can choose to assign a LUT via OCIO down here, which is useful if you're working in a studio where they may have a specific viewing LUT that you should use for viewing your renders with. Below this, we have the render history bar. So you can take a snapshot of a render, and then once you've made a few changes, for example, we'll do that, and then snapshot that, and we'll do a blue one, and snapshot that. Then we can switch back through our old renders. So this is great when you're doing look dev and you want to compare the changes you've made between different settings. Finally, on the right, the display options provides controls for various overlays and additional information. Most importantly, in my view, it allows you to choose a background for your render, which you can do with the display options dialog here. So you have a file browser there, you can choose whatever you want, and then that will be displayed behind any images which have an alpha channel. Although you do need to remember to click transparency on, otherwise it will ignore the alpha channel. The last thing to know about the render view is that you can limit re-rendering to a region of the image by shift dragging. So if I start that render again, I can shift drag here, and it will only update that area, or I can choose a different region. And then I can shift click outside the whole window, or rather outside the whole image, and it will go back to updating the entire image. The next way to start a mantra render is with the Render Region tool in the viewport. The controls are similar to those in the render view pane, but of course with the advantage of not having to leave the viewport. You can find the Render Region tool on the left side of the viewport, right here. So I'm just going to drag a region, and it'll kick off a render. There we go. And this has the same controls as the render view along the top bar. So you can change whether you want it to be progressive refinement, or gradual refinement, I should say. You can control the anti-aliasing from sharp to blur. And you can, because it's updating in real time, you can change things like light colors. And I'll set that back to white. You can drag a larger or a smaller region. You can move it around. So this is great if you want a really quick idea of what's going on with your render. And I'm happy with that, so I'm going to close it. Finally, we can kick off a Mantra render to mplay, Houdini's standalone image viewer. We can do this by clicking on this film spool icon on the bottom left corner of the viewport and choosing a ROP to render. As you can see, there's three options here. There's view mantra, view renderman, and r ROP, mantra_rubble. The first two will be auto-generated, and in fact, I don't believe I have renderman installed on this system, so I don't think that would do much for us. But we'll choose this one. So mplay should appear in a second. And you'll see that we don't have the gradual refinement option because we're using the full Mantra production renderer. But we do get to click in the frame to prioritize the area of the frame we want to see rendered. mplay has most of the same controls that we've seen in the render view. So we have our color correction bar down here, we have our image controls up here. It also has some additional abilities. For example, we can add a frame comment with Alt-C. So I'm going to do that now. I can just type some notes and hit accept, and those will appear on the corner of the frame. I find this very useful for look dev and for optimizing renders. If I'm rendering successive frames and I'm tuning settings, it's good to be able to make a note of what you've changed so that you can go back and replicate those settings if you come across something good. Okay, I'm going to stop that render and close mplay. So far, our renders look pretty flat grey, so let's add some shaders. As with the ROP context and the ROPnet we ended up using, there's a choice to be made about where to keep your shaders. You can put them in Houdini's default location, which is /mat, which is here, or you can create a mat net for them, which is what I'm going to do. So I'm going to hit tab, and I'm going to tab down a material network. I'll drop that there, and then dive inside. So we can create shaders directly inside the material network. I'm going to tab down a principled shader. There it is. But the shaders created here are completely bare default shaders. They don't have any presets, they don't have any textures assigned to them. So you need to add all of that yourself. So in this case, I'm going to delete this one, and I'm going to go to the material palette, which is stocked with pre-set up shaders, which have textures and all of the parameters have been adjusted so that they have a particular look. So I'm going to choose a black rubber shader, and I'm going to put it inside our mat net by dragging it down here and letting go. If I expand this, we can see that it's there. And then I'll do the same with a white porcelain shader. There we go. And then we can jump into the mat net just by double clicking on one of these. So there they are, two shaders next to each other. And when we want to assign these, we can assign them just by dragging them into the viewport onto the object we want. So there's the black rubber shader and there's the porcelain shader. That's pretty simple. Or we can jump up to the object level. We can select the object that we're assigning the shaders to, and we can assign them using the material parameter under the render tab. So we can see that that has the white porcelain shader assigned to it. I can choose another shader. I'll choose the black rubber shader and hit accept, and that's now assigned. However, many times for greater control over how shaders are being assigned, it's better to assign them in the SOP context. So we're going to dive inside this object, and we're going to put down a material node and just drop it on the wire between our object merge and our render. Then I can choose a shader from here. So I'll choose black rubber and hit accept, and we can see that that has been assigned. And then inside SOPs, we can select particular components of our object, like I'm doing here. And then hovering over the viewport, we can tab down another material SOP. And then we can assign a different shader just to those components, like so. So I'll jump back up to the object level and I'll go into the render view and we'll see how that looks. And there you see that we have a kind of checkerboard effect. As a side note, it's worth having a look at how that shading information has been attached to our primitives. So I'm going to right click on this and pop up a spreadsheet and select primitives, and you'll see that there is an attribute called shop_material path, and that tells particular primitives which shader to assign. So that's how it works at the kind of nuts and bolts level. I'll just close that and jump back to the object level. So far we've rendered a single frame, but what if we want to render a sequence of frames? After all, this is an effects rendering course, and the thing about effects is they tend to move. So let's look at how to do that. If we dive inside our ROPNet and select the mantra node that we created earlier, we can see some options for rendering sequences at the top of the pane. The first thing I'm going to do is override our camera resolution, because it takes a little while to render at full res. And then I'm going to set our frame range. It defaults to current frame. I'm going to set it to render frame range, and we're looking at 1 to 240 frames. Then we have 3 different options here. We can render to disk, which will pop up this little progress bar. Unfortunately, this blocks Houdini's UI, so we can't do anything else in Houdini while this is rendering, which is a little bit inconvenient to say the least. So I'm going to interrupt that. We can also render to mplay, which does exactly the same as this, except that it will render it to the mplay viewer. And then this is one I would choose most of the time, render to disk in background. So if I click this, it's going to tell me I need to save my scene file, so let me do that. Control S, render to disk in background. So it tells me that it started a render and that I should use the render scheduler to control it. So I'll open the scheduler, and there's our render. If I close this, I can create another one under render scheduler. There it is. And we can also have one here. So there's one I created earlier, but you can create another one by going to new pane tab type, render scheduler. So I'll let this render and we'll come back shortly and see how to view it. Finally, for this section, we need a way to view our renders. And the answer again is mplay. Let's load up our render and take a look. So we can launch mplay from the command line, but I'm going to do it by going to the render menu, going down to mplay and load disk files. I'll see a dialog box in a second. There we go. And it's defaulting to $hip, which is the directory that you launched Houdini from. So under that directory, our mantra has created a render directory, and we'll see rendered sequences here. By default, this will be shown on a sequence basis, but we can look at individual files if we want to, or go back to sequences. Let's click on that and load it up. Everything looks good. So we can close mplay. So that's it for lesson 1. we've learned how to group our nodes for easy scene readability, how to create lights, how to attach shaders, and how to run test renders and sequence renders of our scene in Mantra. I'll see you in the next lesson.